doing things in reverse. So what is, you said 26?
Yeah.
Oh, yeah, okay.
Is the e just a coefficient and you can bring that out?
Totally. Yeah, negative 5 to 5 e dx. Well, what would I have taken the derivative of to get to just a number? Well, like the derivative of what is 5?
5x.
5x
Yeah, so
plus c, right?
Yeah.
Here's a definite integral, so I'm not going to need the plus c. So this is just e x
Okay.
from negative 5 to 5. Because again, e is just a number. Remember doing the derivatives, and I was so evil, but I did it to you before I graded shit, so I wasn't that evil. I was really just trying to prepare you. So here's an integral of a number. All right, that's going to be number times x, always. What has a slope of e? Well, ex plus c, but the c's cancel for definite intervals, so I don't have to put them down. If the question was this, what would the answer be? Ex plus c. Yeah, mx plus b. It would just be that line. I don't need the plus c here because they would cancel anyway. But it's still, what has a slope of e? Well, ex does. And what has a constant slope? Ex does. I like it. That's a little tricky because it's e and your brain goes, oh, e to the x. There's no to the x piece. It's just a number. I like it. So the integral of pi dx would just be pi x plus c. Same way. Just a number.
Also number 41.
41. Oh, yeah, okay. So, remind me, I don't know why I just did. What is the derivative of 5 to the x, for example? What is that derivative? You have 5 to the x times ln 5. It's one of the easiest rules to forget. Remember that, what's the derivative of e to the x? E to the x. Why is there no thing? Because the ln of e is 1. It's the one thing that where the ln adjustment doesn't show up. Because it doesn't need an adjustment. It's feeling all right. This guy needs an adjustment because otherwise the slope doesn't quite match up. So what's the integral of 5 to the x then? It can't just be 5 to the x. What piece would come out of this derivative that isn't here?
Is it over ln?
Yes, I want you to really start thinking of it that way, because when we get into u sub, there's situations where you don't have to use u sub if you just realize it's not that far off. It's got to be related to 5 to the x. It just has to be. But then you say, well, if I took this guy's derivative, there should be a natural log of 5 here. There isn't. So what must have been here also to kill it? An over natural log of 5. It's trying to be a 5, by the way. So then this guy's derivative would be 5 to the x times ln 5 cancels. And of course that would go away, and that's how you get 5 to the x. How do you check an integral? Take the derivative of the supposed answer. That's also how you can see how to adjust it. You can always adjust a constant. If it's off by a constant, you can adjust it easy. You can't adjust the x piece. That's the part that has to be a certain thing. So like, for example, do you guys get what I mean? If I integrate x squared, I get something like x cubed, right? Is that a cool thing that you guys see? I get something like x cubed. But what is integral x squared exactly? It's not x cubed. It's 1/3. Where the 1/3 come from to kill the 3 that wants to come down? Right? It's the same idea. It's got to be x cubed, and then you adjust the constant to come out to whatever you need it to be. Yes, sir?
It's about it's ln of x over x. That's one of the ones I came across.
Oh, cool. But that's in section 5. It's in the u subsection, right?
Yeah, because that's what I tried to use.
5.5, right?
Couldn't figure it out.
All right, we haven't fully got there, but I mean, let me see. All right. So let's see if the main thing with u sub is, do you see a function in the integral whose derivative is in there also? And that's free to move around, yes. So what's the function in there whose derivative is in there also? What's the function whose derivative is in there? Ln of x. So you let u be that, because then what do you do with u? You take du. And du is what? 1 over x dx. So do you have ln x? Yes. So I can put a u there. Do you have 1 over x dx? Yes, I can rearrange this if you need to. That's the same thing. So that is, what is that? Du. And that is u. Now let go of this shit, because that doesn't matter right now. U sub's purpose is to make an easier problem. You work that problem out, and then you bring back in the ugly shit. So that's your whole world right now. What is that integral? What's the integral of u du? Don't overthink it. What's the integral of x dx? 1/2 x squared. What's the integral of u du? 1/2 u squared. But what was u? There. So you're done. 1/2 ln x squared plus c. It's too nice to believe. So the whole idea of u sub, which is something we're going to get into after we practice just straight up integration first. The whole idea with u sub is there a function in there whose derivative is in there also? And together, do they cover everything in there? Because u sub says, take everything that has an x in it, make it something with a u in it. If you can't do that, you can't use u sub. So if there was like an extra x somewhere, then screw it. U sub would be like, I can't do that shit. Because the whole idea is take an x-related thing, make it a completely u-related thing. Because now I've made that a much easier question about u. What are you about? So then I solve the thing about u, and then I bring back in the stuff about x, because I did the ugly shit already. It made it look a lot better. All right. But u sub always does the same thing. It captures the form of what we're talking about, makes it easier to work with, and then we bring the ugly shit back in at the end. After I'm done. It's fantastic. How do you check this? Put it in Wolfram Alpha. No. How do you check it yourself by hand? You take the derivative and see if you get that. That's the idea, right? If the integral of this is supposed to be that, the derivative of this better be this. Is that cool, right? If you factor something, how can you tell it's right? You multiply the shit back out. You do what would go backwards to check. Same idea. So if the integral of something is supposed to be this other thing, how do you check that? You take derivatives on both sides and make sure that you actually get the inside thing back. Okay, I like it. Anything else from homework stuff?
Number 44 from 5.3. So piecewise.
Let's see.
So would you split up the integrals?
Totally. I love it. This kind of thing is going to happen for a few different reasons to us. And real quick, one of the most evil piecewise functions that doesn't even represent itself as piecewise is the damn absolute value function. I didn't used to feel this way, but over time I've come to realize that they should have never made this damn thing up. But to be honest, it's got applications and everything. Screw it. But this one doesn't have an absolute value. This is not the reason. It's a pure, in-your-face, piecewise thing. What did it say? Which one was it? 44?
Yeah.
2, negative 2 to 0, and 4 minus x squared from 0 to, what's it, 2? There you go, Jeff. So, and they wanted to know the integral from negative 2 to 2, f of x. Well, f of x is different for different values of x. So do you see how that naturally says you got to break this integral up? And of course, how do you break it up? Well, you break it up based on how it's defined. You break it up from plus what's this first one going to be? Probably related to
Negative 2 to 0.
-2 to 0. F is defined to be 2. And then from 0 to 2, F is defined to be
4 minus.
sweet. Now, what's interesting about integrals, I want you guys to realize this. Does anyone have a problem with the fact that the second integral, 0, is not included? And somehow I'm putting a 0 there. On one level, you should have a problem with that. But then there's a higher level to get to where you realize you shouldn't have a problem with that, because any specific point has no area to it. So I never really include the endpoints anyway, because they don't contribute any real area, do they? How much area would 0 try to contribute? None. By itself, it doesn't contribute any area. So the endpoints are just actually kind of limit ideas. I don't actually include them. That's why it's completely fine to have an integral where I'm not really defined at one of the endpoints. All right, maybe. Now, if it went infinity at 0, that could be a problem. But it doesn't do that, so we're fine. Okay, I like it. Another way, does the limit as x approaches 0 of this exist? Yes, so it's fine. If the limit as x approaches 0 did not exist, that could be a problem. Then the integral gets freaky. Is everybody cool with that fact? That's a piecewise problem. There might be an absolute value problem in your future on one of these handouts I'm going to give you. There is. So you got to realize that an absolute value is a piecewise function in disguise. It's so evil. Anything else from homework stuff? What have I not done from 5.3 yet? Okay, so let's do this. I'm going to give you guys this guy. Let me see, where is this? It's coming out. Oh, all right, let's do this first. This is the one that I hope I have enough. One, two, three, four, five, six, seven, eight. No, this is the one I got to go back and get some. So we're going to work on this sheet. The very last one says use partial fractions. I've got a sheet that's a review of partial fractions, but that's the one that the printer decided to just go, here's some weird shit. So I'm hoping. All right, so I want you to work on these. You can work alone. You can work together or not. It doesn't matter. Don't forget now, we got a quiz tomorrow. I announced that yesterday. What did I say? 4.9 through 5.3? Is that what I said? Okay. Just to remind you guys, quiz tomorrow. Bless you. We don't need this going.